In this section, I would like to administrate one of the OOP concepts that are a bit less stressed, and I would like to stress it here before going to the next topic about the abstract classes. Again, the concepts aren't that easy to administrate in Python like in others, but still it's good to know about it. So the core of the abstraction idea may be illustrated through the what versus how thing. When you drive a car or learn driving, you actually, and most of the people, do not care about the details of many of this car. I already gave you before like a homework about the what versus how in the first time learning about the class, I guess, the OOP section. And it should be clear that there is a big difference between what and how. In practice, most of the users focus on the what, not the how, and you do that a lot in your life. Like when we learned about the power function, you didn't care something like power 2 to the power 3 minus 3.2. How is that implemented? You don't care. You just care how is it computed. We can notice that the what is mainly focusing on what the function is going to do, but the how can be implemented in many different ways. An example that we administrated before is the summation from 1 to n, which we can do with loop, which is very slow, or can do it very fast, like sum n times n plus 1 over 2. Sometimes even like our implementation might be buggy, might be not stable enough, might take a lot of memory like in Chrome, and so on. So we can see that the what is same, but the how is going to be changed from time to time. And in many cases, we might even change the inner implementations of something, but the user isn't affected. It's just like we fixed the bug or made something a bit faster. Now, moving a little bit more steps toward the abstraction concept in OOP. The abstraction concept is about hiding unwanted details while showing what's essential in a given context. The statement would be very fuzzy. It's more explained and administrated in C++ and Java, because in this language we have something like the public and private. So the culture in this programming language is to hide as much as you could and only show a few things according to what you are providing. But this culture, as you know, isn't supported in Python as we learned before. Now, what I would like to think about it here in a Pythonic context is abstract is more about focusing on the high level, focusing on the what more than on the how. When you do that with something, then this something is involved with an abstraction step. Remember in the previous lecture, we learned about the algorithm that has an abstracted step that the child class is going to do. We don't care which child, how, we just care that he is going to do it. This is mainly what is abstraction. I don't want to go off topic a lot, but abstraction is a very popular concept in computer science. It appears in many different things. And you will notice that many smart guys will have high abstraction skills. You can see that in algorithms, in problem solving, in management. For example, let's say you are the CEO of a company like Amazon.com. In Amazon, there are too many people and too many projects and too many details. The CEO at a high level cannot be exposed to all of the details. So the guys abstract the information for him. They hide all of the unwanted details and they show only the essential details according to the problem that they are trying to solve. This is what we mean by abstraction. Let's read this class. We have here a shape class that has an area method. But how the area method is implemented, we don't care. This is a hidden information that we don't care about its details. All the shape class is caring about it according to this implementation. There should be some area function. One of my children have to implement it, and that's all. So we are hiding or abstracting the details of the how and focusing only on the what. We already saw these two code snippets in the previous session. I would like you to take a single moment and guess what's still wrong here. What can be improved? The point here is, as we know so far, the shape class doesn't care about the how of the area function, and in all cases it cannot provide an implementation to it. So one of the problem here, if the user mistakenly created an object from shape and tried to call an area, he will fail here by raising an error. And if you try to do that in the second way, it's going to tell him that the area property or attribute does not exist. Actually, this shape class is what we call an incomplete class. You shouldn't create an object from the shape. You have to create an object from a child that is going to implement what the shape class is missing here. Because the shape class only cares that I have the what, but one of my children has to implement the how. And this is where the concept of abstract classes comes. The abstract mainly describe the behavior of an incomplete class. Incomplete, like shape class, it means there is something that we know about its what, but some of its how isn't given so far. So one of the derived classes has to implement the missing part. That's why the concept of abstraction comes. So any moment that you depend that there is a specific information implementation must come from a child class, this is where the word abstract come in a Pythonic context. Python allows us to mark a class or a method as an abstract, so that we cannot create an object from an abstract class that has an abstract method. An abstract method is a method that the child class has to implement. An abstract class is a class that has some abstract methods that someone should implement. In the next session, we will start to administrate how to implement abstract classes.